Let's read the question. Okay, a point moves along a arc of a circle of radius r. So there is a circle of radius r. Okay, and there is a point in this circle that moves along this circular path. Okay, its velocity depends upon the distance s, as v is equals to a under root s. So the velocity at any instant is equals to a, which is a constant, under root s, where s is the distance covered. Can I write this under root s as s to the power 1 by 2? Okay, where a is constant. See, in irodov, wherever acceleration is given, most of the variable a is not acceleration, it's a constant variable. Okay, so make sure while solving irodov you take note of this one. The question is asking, find the angle alpha between the vector of total acceleration and the velocity vector as a function of x. So what is the meaning of this question? The meaning of this question is, see out here, since the velocity is not constant, velocity is variable, so therefore there will be an acceleration along this direction, and that acceleration is called tangential acceleration. See, the tangential acceleration is instantaneous. Now there is one more acceleration required to keep this particle in the circular orbit, and that acceleration is called centripetal acceleration, and centripetal acceleration is also known as radial acceleration. Now the question is asking, see, this tangential acceleration and centripetal acceleration, if I add these two, I'd get the total acceleration vector, total acceleration. And what is the direction of velocity vector? The direction of velocity vector is always along the tangential acceleration. Find the angle between velocity vector and total acceleration. That is our question. Okay, I have to find out this value of alpha. So my approach here should be tan alpha is equals to perpendicular by base, or centripetal acceleration by tangential acceleration. Tan alpha is equals to perpendicular divided by base. Okay, now let's solve the question. What is tangential acceleration? Is nothing but v dv by ds. If I substitute the value of v out here, and I get tangential acceleration is equals to a s to the power 1 by 2 into d a s to the power 1 by 2 divided by ds. Or out here, I'd get the value of tangential acceleration as a square 1 by 2 into s to the power plus 1 by 2 minus 1 by 2. See, solve this and we'll get this equation. Or at would be a square by 2. So the value of tangential acceleration is equals to a square by 2, where a is a constant. Now what is the value of centripetal acceleration? The value of centripetal acceleration is nothing but v square by r. What is the value of v? The value of v is nothing but a s to the power 1 by 2 whole square divided by r. Or centripetal acceleration is equals to a square s by r. Okay. Now if I apply this approach, tan alpha is equals to centripetal acceleration divided by tangential acceleration. Or out here, tan alpha is equals to, what is the value of centripetal acceleration? A square is by r divided by, what is the value of tangential acceleration? A square by 2. A square and a square gets cancelled, or tan alpha is equals to how much? 2s by r. 2s by r. So the question was simple enough. See this question. Okay, a particle moves along a arc of circle of radius r according to the law L is equals to a sine omega t, where L is the displacement from the initial position measured along the arc. A and omega are constant. Okay, so this is a particle that is moving in a circular orbit. Okay, suppose the particle started out here. Okay, it moved along L distance, but L is given by a sine omega t. Okay, this length L is given by a sine omega t, where t is the time. So what is the velocity? Velocity is nothing but dl by dt. Okay, which is nothing but a omega cos omega t. Okay, I got the velocity out here. What is the acceleration? Acceleration is nothing but dv by dt. Okay, so dv by dt is nothing but, when we differentiate this with respect to t, what do we get? A omega square sine omega t minus. Okay, so out here acceleration is nothing but minus a omega square sine omega t. I'm not going into the details of differentiation and integration right now. Okay, so at this instant the velocity is given by a omega cos omega t, and the acceleration is given by minus a omega square sine omega t. Note one thing out here. The acceleration is along this direction. And what is the acceleration along this direction called? Tangential acceleration. So this is nothing but tangential acceleration. And in circular orbit, there is another acceleration. What is that acceleration called? Centripetal acceleration or radial acceleration. And what is the formula for centripetal acceleration? V square by R, where V is equals to a omega cos omega t whole square by R, or is equals to centripetal acceleration is equals to a square omega square cos square omega t divided by R. So we have determined these three values. Okay, now let's read the question. The magnitude of total acceleration of the particle at point L is equals to 0 and L is equals to plus minus a. Okay, so what is the total acceleration? Total acceleration is equals to tangential acceleration plus centripetal acceleration. Okay, what is the value of tangential acceleration? Minus a omega square sine omega t whole square. What is the value of centripetal acceleration? A square omega square cos square omega t divided by r whole square. Okay, this is the value of total acceleration. Okay, so total acceleration is equals to a square omega to the power 4 sine square omega t plus a to the power 4 omega to the power 4 cos to the power 4 omega t divided by r. Okay, or what is the value of a square omega to the power 4? Or if I take a square and omega to the power 4 common out here, I'm left with how much? Sine square omega t plus a square by r into cos to the power 4 omega t. Or a square omega to the power 4 is nothing but a omega square. If I take the a square omega to the power 4, I'm taking this one outside the root. Okay, is equals to sine square omega t plus a square by r cos to the power 4 omega t. This is the value of total acceleration. total acceleration. Now I need to find out the total acceleration at 2 points. At L is equals to 0. So point number A at L is equals to 0. So at L is equals to 0, there is no parameter of L out here. See, so how do I find out at L is equals to 0? See, in the question it is given as L is equals to A sine omega t, which is equals to 0. So from this we can easily say that omega t is equals to 0. Okay, so if we substitute omega t is equals to 0 out here and omega t is equals to 0 out here, what do we get? Total acceleration is equals to a omega square into sine square 0 is nothing but 0 plus cos squared is cos to the power 4 0 is nothing but 1, or a square by r, or total acceleration is equals to a square omega square by under root of r. Okay, Achha. There is a small error out here. This is r square, this is r square, this is r square. Okay, out here also r square, and this would be r. Okay, a square omega square divided by r. Similarly, at L is equals to plus minus a, or L, okay, a part 2. L is equals to plus minus a, which is equals to a sine omega t. Why? Because the value of L is nothing but a sine omega t. Okay. Or if I take this both equation, plus minus a is equals to a sine omega t, a and a would get cancelled, or plus minus 1 is equals to sine omega t is equals to sine omega t, but the value of 1 would be nothing but sine pi by 2 is nothing but 1. Okay, so omega t is equals to pi by 2. Okay, or minus 1, it can be minus pi by 2. Okay, plus minus pi by 2, it doesn't matter. See, even at plus pi by 2 cos is 0 and minus pi by 2 cos is 0, so it will not matter out there. Okay, total acceleration out here is equals to how much? Total acceleration was a omega square sine square omega t plus what? A square by r square cos to the power 4 omega t. And you have to substitute the value of omega t is equals to pi by 2. So if we substitute, total acceleration is equals to a omega square. Achha, let's write it at the bottom. So total acceleration is equals to a omega square. What is sine square pi by 2 is nothing but 1. What is cos square pi by 2 is nothing but 0. See, and 0 to the power 4 is nothing but 0. Or total acceleration is equals to a omega square. Now the second part of the question, the minimum value of total acceleration corresponding to displacement L. Whenever minimum or maximum is asked, just differentiate it and make it equals to 0. So differentiate with respect to what? See, in this equation, I get total acceleration with respect to time. What is the only variable out here? A is constant, omega is constant. The only variable is time. So if I plot a graph of A versus time, I don't know how the graph will look like, but I do know at maximum and at minimum dA by dt will be equals to 0. So I would not go into the details whether it's maximum or minimum. That will come in the chapter of monotonicity in mathematics. But in physics, whenever maximum or minimum is asked, just differentiate and make it equals to 0. Okay, so somehow I have to differentiate this entire term and make it is equals to 0. Okay, so out here minus a omega square sine omega t whole square plus a square omega square cos square omega t by r whole square should be equals to, or d by dt should be equals to 0. So instead of making the sum lengthy, let us simplify out here only. Okay, see, minus whole square would be positive. Okay, a omega square is nothing but a square omega to the power 4. So I'm removing this, and a square omega to the power 4 sine square omega t. Okay, so I have simplified this one. Okay, similarly out here a square omega square whole square is nothing but a to the power 4 omega to the power 4 omega to the power 4 cos square whole square is nothing but cos to the power 4 and r square, then I would omit this whole square. Okay, okay, now let's compress this. That means I'm bringing this entire term. Okay, bringing this entire term, it will be this side. Okay, and instead of making it neat, let's take the constant out here. See, what can I take constant? A square omega to the power 4 can be taken as constant. Okay, so differentiation of any constant is equals to 0. So if I take omega to the power 4, I can take the constant outside, no? Outside differentiation. Okay, so omega to the power 4. So I've omitted omega to the power 4 out here, omega to the power 4 out here. I can take a square common. A square, if I take a square common out here, it would be a square. Okay, and this can be equated with 0. Okay, which is equals to 0. This can be equated with respect to 0. Okay, just divide by 0. Divide left hand side and right hand side by the same unit, and it will be equals to 0. Okay, now let's differentiate this term with respect to 0. Okay, let's compress this term sine square omega t. So I'm writing sine square omega t out here. Okay, and a square cos to the power 4 omega t by r square plus a square cos to the power 4 omega t by r square. Okay, closing the bracket, divided by dt, divided by dt should be equals to 0. So this is our simplification. Okay, now how do I solve this? See, differentiation of sine square omega t is nothing but 2 sine omega t into omega. So 2 omega sine omega t, 2 omega sine omega t. If I differentiate this parameter is with respect to time, is nothing but a square by r into 4 cos cube omega t into omega. Okay, and one more thing, I made a mistake out here. Okay, even I forgot elementary differentiation. See, if I differentiate sine square omega t is nothing but 2 sine omega t into cos omega t into omega. Okay, differentiation of a square cos to the power 4 omega t. So a square by r square, I'm taking constant outside, into 4 cos cube omega t into minus of sine omega t into omega. Okay, should be equals to 0. So if I simplify this one, 2 omega, 2 omega sine omega t cos omega t minus how much? 4 a square by r square, okay, into omega, okay, cos cube omega t into sine omega t should be equals to 0. See, 4a square divided by r square cos cube omega t into omega. Okay. So now I must solve this equation. How to solve this equation? Can I send this entire term to the right hand side? Okay, so it would be equals to somewhat like this. Okay. Now can I cancel omega and omega? Of course, omega and omega got cancelled. Okay. Can I cancel 2 and 2? Okay. So out here 2 got cancelled and this 4 became 2. Okay. Can I cancel sine omega t, sine omega t? Yes. So sine omega t and sine omega t got cancelled. Okay. Can I cancel cos omega t and square? Of course. So cos omega t became 1 and this is nothing but cos square omega t. Okay. So I can rewrite this equation as r square by 2a square is equals to cos square omega t. Okay. Or r by root 2a is equals to cos omega t. Now note out here, I found the value of cos omega t, but the question is asking minimum value of total acceleration. But the expression for total acceleration is this one. Okay, so how do I substitute cos omega t? I can substitute easily out here. But what about sine omega t? See out here. Okay, so for minimum acceleration, the value of cos omega t is equals to r by root 2a. So how do we find out the value of total minimum acceleration? See, I can simply write it as cos square omega t is equals to r square by 2a square. I'm squaring both the sides. Why am I squaring? To substitute out here. But what about sine square omega t? See, according to a trigonometric function, sine square theta plus cos square theta or omega t is equals to 1. Okay, cos omega t is nothing but r square by 2a square, or sine square omega t is equals to 1 minus r square by 2a square. I'm taking this cos omega t to the right hand side. So this is our equation number 2. This is our equation number 1. And the value of total minimum acceleration. Total minimum acceleration is nothing but a square omega to the power 4 sine square omega t plus a to the power 4 omega to the power 4 divided by r square cos to the power 4 omega t under root. Okay, I substitute the value of cos square omega t as r square by 2a square. So out here cos to the power 4 omega t is nothing but r square by 2a square whole square. Okay, because out here this is cos square and this is cos to the power 4. Similarly, sine square omega t is nothing but 1 minus r square by 2a square. Okay, so out here I'm taking a square and omega to the power 4 outside. So total minimum acceleration is equals to how much? Is equals to a omega square, okay, into 1 minus r square by 2a square, which is equals to sine square omega t, plus I have took a square omega to the power 4. No? So remaining is a square by r square into r to the power 4 by 4 a to the power 4. So r square, a square, a square. Okay, let's make it neat and clean. R square by a square, r square by a square. Okay, let's take this inside, plus r square by 4a square, and let's remove this instead of making it long. I'm just making it neat and clean. Or total minimum acceleration. Okay, I'm just abbreviating the term. A omega square 1 minus r square by 2a square plus, this is nothing but minus 1 by 2 plus 1 by 4, which is nothing but minus 1 by 4. So minus r square by 4 a square. This is the value of total minimum acceleration. And the next part of the question was the corresponding displacement L at minimum acceleration. So L is equals to A sine omega t, and at minimum acceleration the value of sine square omega t is nothing but 1 minus r square by 2a square, or sine omega t is nothing but 1 minus r square by 2a square to the power 1 by 2. Okay, or L minimum is equals to A into 1 minus r square by 2a square to the power 1 by 2. Or if I send the a inside, it will be L minimum is equals to k a square minus r square by 2. Okay. Okay. A point moves in a plane so that its tangential acceleration is equals to a. So suppose in a plane it moves along a radius of curvature, whatever the radius of curvature is. Okay. This is not perfect circle. Okay. So suppose out here the point was moving with velocity v. The tangential acceleration is given by a constant a. The normal acceleration is given by b t to the power 4. See, and its normal acceleration is b t to the power 4. Okay, where a and b are constants, positive constants, and t is time. At the moment t is equals to 0, the point was at rest. That means they're giving boundary condition out here. So boundary condition at t is equals to 0, v is equals to 0, or initial velocity is equals to 0, and initial displacement is equals to 0. The question is asking, find how the curvature radius r of the point trajectory and total acceleration depends upon the distance covered x. That means what the question is asking is, find the value of r as a function of s. Okay, and find the value of total acceleration. What is total acceleration in circular motion? Total acceleration is nothing but combination of tangential and centripetal. And always remember, tangential and centripetal acceleration are always perpendicular to each other. Okay, total acceleration as a function of distance covered. So let us solve for the first part. Okay, out here, tangential acceleration is equals to some constant. And what is tangential acceleration? dv by dt is equals to some constant, or dv is equals to a dt, or v is equals to at plus some constant. Now applying BC, applying boundary conditions. What are the boundary conditions? At t is equals to 0, v is equals to 0. We get the value of constant is equals to 0. So our main equation becomes v is equals to 80. Okay. Now using v is equals to 80, v can also be written as ds by dt. ds by dt is equals to 80, or ds is equals to 80 dt, or s is equals to 80 square by 2 plus some constant. Okay, applying boundary condition at t is equals to 0, s is equals to 0. Why did I apply s is equals to 0 at t is equals to 0? At initial time, the total distance traveled is equals to 0. Before starting of motion, there is no distance traveled, no? So at t is equals to 0, s is equals to 0. Okay, so out here, if I apply this boundary condition out here, the value of constant becomes 0. Or our main equation becomes s is equals to 80 square by 2. Okay, now the second part of the question. Okay, see, I need to find out the value of r as a function of s. Okay, the value of r as a function of s. Okay, what is centripetal acceleration in circular motion? Is always v square by r, or r is equals to v square by centripetal acceleration. Okay, what is the value of v? The value of v is nothing but a into t. The value of v is nothing but a into t. So can you substitute this value out here? So r is equals to v square, or at whole square, divided by what is the value of centripetal acceleration. Centripetal acceleration is nothing but given by normal acceleration, or b to the power 4. b to the power 4. If we solve this one, we get r is equals to a square by b t square. Problem is, they have asked in the question find r as a function of x, but we have found out r as a function of time. So we must replace this t square with s. How do I replace it? Using this one. That's why I got the equation of distance from the equation, or 2s by a is equals to t square. So now when we substitute this t square out here, we get r as a function of s. R is equals to a square by b into 2s by a, or r is equals to a cube by 2bs. So r is equals to a cube by 2bs. So we find out the first part of the question. Okay, r as a function of s. R as a function of s. Now we have to find out the second part of the question, total acceleration as a function of s. Okay, to find out total acceleration, what is total acceleration? A combination of normal acceleration or centripetal acceleration plus tangential acceleration. So total acceleration is equals to under root of tangential acceleration square plus centripetal acceleration square, where tangential acceleration is given as constant a. This is a tangential acceleration a. Okay, and what was I? This centripetal acceleration is given as, what is the value of centripetal acceleration? B t to the power 4. See, we must substitute centripetal acceleration with function of s. See, I can easily substitute centripetal acceleration as b to the power 4, but the question is asking find out the total acceleration as a function of s. So can I substitute this t to the power 4 with s? See, this t to the power 4 can be written as t square whole square. Okay, and from out here, where from this equation, t square is equals to 2s by a. So our omega n is equals to how much? D into t square. What is the value of t square? 2s by a whole square. Okay, or when I substitute this out here, I get omega n is equals to 2 bs. Acha, let's write this properly. Okay, b into 4 a square by a square. 4 a square by a square is the value of centripetal acceleration whole square, or out here a square plus 16 b square is to the power 4 by a square. This is the value of centripetal acceleration. So our total acceleration would be nothing but this term, total acceleration as a function of s. So therefore total acceleration is equals to under root of a square plus 16 b square s to the power 4 divided by a square. Okay, now one more thing, in some books this is written as a square by 2bs. That's really wrong. See, if you do the dimensional analysis, that solution or those kind of solution would be wrong. Okay, so whenever you're confused about the answer, just do a quick dimensional analysis. Okay, see this question. Okay, a particle moves along the plane trajectory y is equals to x with velocity v whose modulus is constant. That means what this question is telling is it is moving with constant speed. That means speed is constant. Speed of the particle is constant. Okay, this entire sentence means speed of the particle is constant. Find the acceleration of the particle at point x is equals to 0 and the curvature of the trajectory at the point to the trajectory has the form y is equals to ax square and ellipse x by a square plus y by b square is equals to 1. Okay, now there are two important concepts that you have to know. Okay, in any type of arc motion, not necessarily circular motion, suppose it is moving with v. Okay, what does Newton's first law say? In order for this particle, suppose a particle is moving with velocity v. Okay, now if there was no acceleration, what would happen? Wait, just let me. Suppose this particle was moving with velocity v. Okay, if there was no acceleration out here, what would happen? The particle would continue moving in a straight line. Newton's first law. Okay, so in order for this particle to change the path, what would happen? Okay, there needs to be an acceleration to change the direction of velocity vector, and that acceleration is called centripetal acceleration or radial acceleration, and the formula is v square by r, and this r out here is nothing but radius of curvature. Understood? And the second thing you need to learn is the type of curves they are discussing in the question. So you need to have a basic idea. Y is equals to ax square. This curve looks somewhat like this. Okay, like this. Okay, this is the value of, or this is the graph of y is equals to ax square. Roughly, this is the graph. Okay, it will depend upon the value of how the slope of this curve will depend, but this is the rough sketch. Okay, Now this particle out here was moving with constant velocity along this path. Okay, the question is asking, when the particle was at x is equals to 0, that means at particle x is equals to this velocity v, what is the radius of curvature? That means what is the radius of curvature? That means what is this radius of curvature of the particle at x is equals to 0? So you automatically get the idea that you have to find out the acceleration in y component. Okay, acceleration in y component, and as soon as we find the acceleration in y component, what do we get? We get this value. If I get the velocity, I can automatically find the value of r. Problem is, the question is saying they're moving with constant speed along this path. So at x is equals to 0, the velocity vector would be along x-axis. Okay, this much is understood. So let me write, at x is equals to 0, velocity vector is along x-axis. Okay, and this velocity vector along x-axis has a constant value. So therefore tangential acceleration or acceleration in this direction would be equals to 0. Therefore, since speed is constant, we haven't arrived at the problem solving, I'm just giving you the approach. Since speed is constant, tangential acceleration, which means acceleration in this direction, tangential acceleration is equals to 0. Okay, and since this particle would move along this line, so therefore there is some acceleration in y component that is changing the direction of this particle along this curve. We need to find out this value of acceleration. Okay, now how do we find it out? Let's see. The equation is y is equals to ax square. So can I write dy by dt is equals to d ax square by dt? Now in mathematics, in the chapter of differentiation, there is something called chain rule, which I can write as dy by dt is equals to d into ax square by dx into dx by dt. Okay, what is dy by dt? Velocity of y component. Okay, what is the differentiation of this? 2ax. And what is dx by dt? Velocity of x component. So from this relation I get vy, or y component of velocity, is equals to 2ax into vx. This is our first equation. But the problem out here is I cannot do anything with this equation. Okay, I need the acceleration. I need this value of acceleration. No? How do I get this acceleration? Let's differentiate this equation again. So dvy by dt is equals to 2ax vx divided by dt. Again, when we apply chain rule, we get, what is dvy by dt? Dvy by dt is nothing but acceleration in y component is equals to d into 2a x vx by dx into dx by dt. Okay, since there is some lacking space, I'll just solve it. I'll try to solve it out here. Okay, see, out here dx by dt can be written as vx, or x component of velocity. So let's write this as x component of velocity. Okay. This 2a is constant, so can I take this 2a outside into 2a, or let's write this neatly as 2a vx, 2a vx. Okay, let's write this closely, x vx dx x vx. Okay, now dx into vx can be written as, see, I'm just moving this closer. Okay, into 2a vx, 2a vx. So I'll erase this one. Achha. This can be written as ay is equals to x into dvx by dx plus vx into dx by dx, okay, into 2a vx. Okay, now I'll take this equation on the next page. Acha. Or see out here, ay is equals to 2a into x vx dvx by dx. What I'm doing is I'm multiplying this vx term inside the bracket, okay, plus vx square into dx by dx. Okay, dx by dx is nothing but 1. This dx by dx is nothing but 1. So this is nothing but 1. Okay, vx into dvx by dx. Acha, vx into dv by dx. V dv by dx or v dv by ds. What was v dv by ds? Is nothing but acceleration in y x component, no? Is equals to ax. Okay, so can I substitute this out here? Of course I can. So this can be written as ax. Ax. Okay, so if I rewrite this equation, it will be something in the manner of ay is equals to 2a into x ax plus vx square. Okay, this is our equation. Now the question was asking, find the acceleration when the particle was out here. Out here the particle has vx. What is the value of vx? The value of vx is nothing but the velocity v. Why? Because it is moving with constant velocity v. So vx will become v. What is the value of x? It will become 0. So y component of acceleration is nothing but 2a into vx square. Okay, or 2a into v square. V square. Now I need to find out the radius of curvature. How do I find out the radius of curvature? Centripetal acceleration is equals to v square by r, where r is equals to v square by centripetal acceleration. What is the v square value of v square? The value of v square is nothing but this v square, or r is equals to v square, and what is the value of centripetal acceleration? 2a v square. This v square and v square will get cut, and r is equals to 1 by 2. So this is the first part of the equation. Now the second part of the question. Okay, the ellipse of y is equals to x by a square plus y by b square, where a and b are constant. So apply the same approach out here. The graph of x square by a square plus y square by b square is equals to 1 looks something like an ellipse. Okay, where x at x is equals to 0, this is equals to b, this is equals to b, and this is equals to a, this is equals to a. Okay, and the particle is moving around this ellipse with constant velocity v. Okay, so apply the same approach. D x square by a square divided by dt plus d y square by b square divided by dt is equals to d of 1 by dt. Okay, why do we do that? To find out the velocity. And why do we need to find out the velocity? To find out the acceleration. So 1 is a constant, so differentiation of any constant is equals to 0. Okay, dx square by a square can be written as dx square by a square divided by dx into dx by dt. Why? I'm applying chain rule. Why am I applying chain rule? Because x square by a square has no parameter of t, plus d by dy into y square by b square into dy by dt. Similarly, I apply chain rule out here. is equals to 0 is equals to 0. Okay. Now what is dx by dt? What is this dx by dt? Dx by dt is nothing but vx, or velocity in x component. What is dy by dt? Dy by dt is nothing but vy. Okay. Now let's differentiate this. X square by a square, where a square is constant. So 2x by a square into vx plus 2y by b square into vy is equals to 0. Okay. Can I take 2 common out here? Of course I can take, or 2 into x by a square vx plus y by b square vy is equals to 0. So I can eliminate this 0. Sorry, I can eliminate this 2. Okay, divided by 2, 0 divided by 2 is 0. So I get a relation of this one. Now I have to differentiate this again. Why? Because this particle is moving with a constant velocity. It can move clockwise or anti-clockwise. The question isn't specified. Okay, but at x is equals to 0, suppose the particle is what out here. It is moving with the velocity v. The particle, let's not take this one. Let's take the particle that is moving with velocity v. Okay, and this component of velocity is vx. Okay, there must be acceleration in this direction ay, and we need to find out the radius of curvature using the formula of center equals to v square by r is equals to v square by r. That is my fundamental for centripetal acceleration. Okay, this is the same fundamental as previous question. Now I have to differentiate this equation with respect to time again. Why? Because I need to find out ay, which is the centripetal acceleration. This ay is nothing but the centripetal acceleration, which is nothing but when I differentiate this equation with respect to time, I get the parameter of ay. Okay. One more doubt some of you have, sir, how do I know you have to differentiate this equation? It comes with a little bit of practice. Okay, let's out it. So 1 by a square into d x vx by dt plus 1 by b square d y vy by dt is equals to 0, or 1 by a square can be written as x d vx by dt plus vx into dx by dt. Okay, addition of plus 1 by b square into y d vy by dt plus vy into dx by dt. Okay, so out here, what is vx by dt? dvx by dt. dx by dt is nothing but acceleration in x component. This is nothing but acceleration in x component. So out here, ax. Okay, this is nothing but acceleration in y, sorry, velocity of x component. So this becomes nothing but vx into vx is nothing but vx square. This vx is multiplied by dx by dt. Dx by dt is nothing but vx only. Okay, fancy form of vx. So it becomes vx square. Similarly out here, it becomes ay into vy square into vy square. Okay, is equals to 0. Y is equals to 0. See the equation. d0 by dt is nothing but 0 only. Okay, now the question is, this is the second equation that I got. Now I'll proceed with the second equation on the next page. Okay, so out here, okay, we need to substitute x is equals to 0. So at x is equals to 0, vx is equals to vy, see, When this particle is moving in an elliptical orbit at x is equals to 0, there is only x component of velocity. Okay, there is no y component of velocity, and vy is equals to 0. So x is equals to 0. Okay, vx is equals to v square, vy is equals to 0, and ay, you need to find out the value of ay. So if I simplify this equation, 1 by a square into v square plus 1 by b square into, at x is equals to 0, at x is equals to 0, what's the value of y? The value of y is nothing but b. See, b. How do I know that? X square by a square plus y square by b square is equals to 1. Okay, at x is equals to 0, y square by b square is equals to 1, so y is equals to b. So out here at x is equals to 0, this value is equals to b, this value is equals to b. Okay, so at y is equals to 0, at x equals to 0, the value of y becomes b. Okay, so b into ay is equals to 0, or v square by a square plus this b and this square gets cancelled, ay by b is equals to 0. And we need to find out the value of ay, or ay, or acceleration in y component, ay is equals to ay by b is equals to minus v square by a square, or ay is equals to minus b v square by a square. Now what is this ay, or acceleration in y component? This acceleration in y component is also the centripetal acceleration, no? But centripetal acceleration is equals to v square by r. Okay, v is the velocity, or r is equals to v square by centripetal acceleration, and centripetal acceleration out here is nothing but ay. Okay, so r is equals to minus v square by a square divided by, sorry, this is v square divided by minus v square by a square. Okay, v square and v square will get cancelled, or r is equals to minus a square by b. Okay, this minus out here is nothing but it will determine in which direction. That means radius of curvature is opposite to the direction of this. See, if this was out here, radius of curvature would be downward, radius of curvature vector would be downward, minus. If the particle was at minus, radius of curvature would be positive or upwards, radius of curvature vector. This r is a vector, that's what this minus signifies. Understood? So this is nothing but radius of curvature for ellipse. This is our question number 1.42 of irodov. Now let's look at this question. Okay, this question is nothing but a simple case of geometry. Let's read the question. A particle M moves along a circle of radius 50 centimeters. It means this particle is moving along this circle and the radius of the circle is equals to 50 centimeters. That means this is equals to 50 centimeters. Okay, so that its radius vector r relative to point O, this is a point O, rotates with a constant angular velocity omega is equals to 0.4 radians per second. So out here omega is equals to 0.4 radians per second, and this rod or this point is moving with constant velocity such that this vector rotates with angular velocity 0.4 radians per second. Okay, find the modulus of velocity of the particle. Okay, that means find the total velocity of the particle, find the velocity of the particle v. Okay, and the modulus and direction of its total acceleration. That means you have to find out the velocity. First part you have to find out the velocity, second part you have to find out total acceleration. Okay, Achha, let's look at this diagram. Okay, r is equals to 50 centimeter. What is this much distance? This much distance is also r, which is equals to 50 centimeter. So let's connect this line r. Now see, can I say this is theta, this is also theta? Okay. Now let's draw a straight line across the spectrum. Okay. That means I'm extending this line across this line. That means this entire thing is a straight line. Okay. If this is theta, this is theta. This angle is nothing but 180 minus 2 theta. Okay. So this is nothing but 180 minus 2 theta, or 2 theta double dash. I'm writing 2 theta double dash is equals to 180 minus 2 theta. This is a convention I'm making so that there is no confusion or the diagram becomes neat and clean. Okay. If this is 180 minus 2 theta and this entire angle is 180, how much is this much angle? This much angle is nothing but 2 theta, because the straight line is 180 degree. Okay. Now see, this is moving with angular velocity omega. Okay. Whatever happens, this particle is moving in a circle, no? Okay. So the velocity will always be tangential to the circle. This velocity will always be tangential to the circle. So this angle will always be 90 degree. This much is understood. Now we use the concept of V is equals to omega into R. In circular motion, you will have studied V is equals to omega R. Okay. S is equals to theta R, and acceleration is equals to alpha R. These three relations you have studied. The actual relations on something in this manner. See, let me write the actual vector relations. Okay, it will be much more easier. S is equals to theta cross R. V is equals to omega cross R. Okay, and A is equals to alpha cross R. These are the relations. So using these three relations of circular motion, I'm going to specifically use this one for number 2. V is equals to omega R. Okay, so let's see this line. Okay, the velocity V is equals to omega into R. Okay, so V is equals to omega into small r. Okay, now let's name the velocity of this C. Since this particle is moving in a circular orbit, this rod or this vector is moving or is rotating around this axis. This vector r, okay, or the radius vector is also rotating around this axis, is also following the particle. So let the angular velocity of the center of the circle be, or let the angular velocity of this line be how much? Say x. Okay, so omega into r is equals to v, which is also equals to x, which is the angular velocity of this line, into capital R, is equals to x into capital R. Okay, understood this much? Now see one more thing out here. Omega is nothing but d theta by dt. Okay, rate of change of angular degree, and x is nothing but d into 2 theta by dt, or rate of change of this angle. Okay, so using this two relation, can I write d theta by dt into r is equals to d of 2 theta by dt into capital R. Okay, okay. What is d theta by dt? Omega, or d theta by dt into small r is equals to, can I take this 2 outside since this 2 is a constant? 2 into d theta by dt capital R, or omega r is equals to 2 into omega capital R. Understood? Which is equals to the velocity of the particle or tangential velocity of the particle, but this is nothing but the tangential velocity of the particle. Okay, so let's take this two equation. Okay, or 2 omega r is equals to tangential velocity. What is the value of omega? 0.40 or 0.4. Okay, what is the value of r, capital R? The value of capital R is nothing but 50 centimeter or 0.5 meter. Okay, it's better to use SI unit 0.5. Okay, so 0.5 into 0.4 is nothing but 0.2, or 2 into 0.2 between 5 to the 20, 2 decimal point 0.2 is equals to Vt, or 0.4 meter per second is equals to tangential velocity. So this velocity is equals to how much? 0.4 meter per second. Okay, see the tangential velocity out here. Okay, now I found out the value of velocity. V is equals to how much? 0.4 meter per second. So V is equals to 0.4 meter per second. Now for the second part of this question, total acceleration. Since this omega is constant, that means this tangential velocity is also constant. The radius will always remain constant, no? Okay. If the radius is constant and omega is constant, this Vt is constant. If Vt is constant, that means the tangential acceleration is how much? 0. Tangential acceleration is equals to 0. And in circular motion, there is another acceleration that is called the centripetal acceleration. And the value of centripetal acceleration is how much? Value of centripetal acceleration or radial acceleration is equals to Vt square by r. Okay, or acceleration is equals to, what is the value of Vt? 0.4 square divided by 0.5, or centripetal acceleration is equals to how much? When we solve this one, we get the value of 1.6 divided by 5. Okay, or 0.16 divided by 0.5. 0.16 divided by 0.5 meter per second square. Now since the tangential acceleration is equals to 0 and the centripetal acceleration is equals to this value, total acceleration is equals to this square plus this square under root, which is equals to this square only, this square under root, which is equals to centripetal acceleration. So the total acceleration is nothing but the centripetal acceleration, which is equals to 0.16 divided by 0.5. Okay, why? Because the tangential acceleration is equals to 0 out. Understood the question?